All right, guys, pre-algebra section 4.1, we're going to be going through different representations of fractions, meaning converting them to decimals and percentages. And there's a nice little graphic organizer in the textbook. This is actually on page 47 if that's something you wanted to take a look at. I know we have the PDF version of the book available. So page 47 kind of walks you through, how do you get from one to the other? If you start with a fraction, let's say you want to start with a fraction but end up as a percent. So you want to go from fraction to percent. So it's kind of telling you the steps to do that up here. We would divide the numerator by the denominator and then move the decimal point 2 spots to the right. That changes you into a percentage. So let's go through a few examples, and again, you can refer back to this for steps and whatnot, but let's see if we can do a few on our own and just kind of talk about the thought process. Okay, so first off, here's a worked out example. Example A, they want us to convert 0.75 to a fraction. Okay, and there's a couple ways to do this. The book uses, to determine the power of 10 in the fraction's denominator, they want you to count the number of digits. And that's kind of one way. I had not seen doing this way, but they're saying, all right, there's 2 digits after the decimal place, right? So what they're saying is that makes the denominator 10 to the second power. Okay, what I've always used, okay, and it's doing the same thing, is just thinking about when you have a decimal. So let's say you have a number like 0.75, like this one. It's just kind of knowing the place value, right? So the whole number is obviously the 0 over here. Then you have the decimal. But then the 7 would be in the tenths place. The 5 would be the hundredths place. And if it kept going, it would be the thousandths, then 10,000th, then 100,000th, and so on. And that's really all that's happening here. Just a little nifty way is if you count the number of decimals, okay, it becomes 10 to the second power, which is 100. Okay, and I was just saying again, recognizing that the 5 is in the hundredths place, so that's how I would come up with the 100 in the denominator. Okay, but anyways, either way works. So you come up with a way that's comfortable for you. So what we're doing, if the decimal again is 0.75, we are taking the 75 goes in the numerator, and then the denominator is 100 again, because there was 2 decimal places after, or there was 2 digits, I should say, after the decimal place. So 0.75 is really 75 over 100, and then all we need to do is reduce the fraction to get it into simplest form. So again, 75 over 100, again, they're both divisible by 25 to reduce as far as we can. Okay, and that gets us our final answer of 3/4. Okay, let's do a couple on our own. Let's see if we can convert and try these decimals into fractions. Okay, so 0.59. So again, I'm starting out counting. After the decimal point, there's a 5 and a 9. So there's a tenths and then there's a hundredths. So this one is going to be 59 over 100. Okay, and then we need to ask ourselves, is that reducible at all in any way? And in this case, I don't think there's any number that goes into both of them. So let's leave that one alone. Okay, part B, 0.4. Okay, there's only 1 digit after the decimal place. So that means it's in the tenths place. So the numerator is 4, the denominator is 10. Okay, those can be reduced. They're both divisible by 2 to give us a final answer of 2 over 5, 2/5. Okay, so 2/5 would be the fractional form of 0.4. All right, example C here, 0.235. So again, let's kind of count these out. The 2 is in the 10th spot, the 3 is in the hundredths, the 5 is in the thousandths then. So this is 235 over 1,000. Okay, and again, the book's way, the little trick in the book was that there were 3 digits past the decimal. So the denominator is going to be 10 to the third power, which equals 1,000. Okay, it's basically telling you the number of zeros after the 1. Okay, now this one is definitely reducible. I know that 5 goes into both of them, so let's divide 235 by 5, and that will get us 47. And if we divide 1,000 by 5, we are getting 200. Okay, so 47 over 200 would be our final answer here. Okay, I just want to show you guys a little quick calculator tip here to do these. For example, if we wanted to do the last one, the 235 over 1,000. So we're just going to use the fraction bar as a division. Okay, and if I just press enter right now, it's going to give me the decimal. It's going to give me back the 0.235. But one little shortcut on here, what you can do, this math button up here, and then the first option is to convert to fraction. And you might be thinking, well, it already is a fraction. But notice what happens when we press it. It gives us the cool, nice, reduced answer. Okay, so really a cool little feature on the graphing calculators. And other calculators may have these as well. But it's definitely a good time saver, and it will reduce things for you nicely. All right, then let's see what we got going on. Some other stuff along here. Janice, right? Remember, I guess we haven't met Janice before. Sometimes they repeat some of these characters in here. But Janice has said that you can remove any zeros after the decimal point before converting to a fraction, okay? Unless they are between non-zero digits. So can we give an example that supports Janice's claim? So let's see. I'm thinking about, let's say our decimal is 0.300 or something like that, okay? And we want to convert that to a fraction. Janice is telling us we can remove any non-zero digits. Can we just write that as 0.3? And is that going to be the same fraction? All right, so let's take a look. If we did the little process to change 0.300, it would be, we have a tenths, hundredths, thousandths. Right? We have 3 digits after the decimal. So this really would be 300 over 1,000, right? Remember, tenths, hundredths, thousandths. And 300 over 1,000, if we were to reduce that, we could divide them both by 100. And that would equal 3 over 10. Okay, why is it not letting me write? Here we go. Now, if we just converted the 0.3 into a fraction, right? The 0.3, it only has 1 digit, so it's a tenths place. It would be 3 over 10. Is that equal? Yeah, right? 3/10 equals 3/10. So can we always remove any zeros after the decimal point as long as they're between non-zero digits? Can we do that? Let's see. What if we said something like this? And let's put a 0 there. Can I remove those? Is that the same as like what Janice said? Well, let's just remove the non-zeros and make it 0.3. Is that the same? And in this case, the answer is no, right? The first problem, 0.0003, so that's tenths, hundredths, thousandths, 10,000ths. So this is really 3 over 10,000. While this one, as we saw before, there's only 1 digit, so that's the tenths. It's 3/10, and these obviously are not equal. Okay, so you just got to be careful. You are able to remove zeros if they are after non-zero entries. Okay, like these zeros in this first one, there's no other digits after them. Okay, but in the other case, in this problem, these zeros are what's called, or they're just, they matter, right? They change things quite a bit. Okay, and you'll talk maybe more about that in science class and the significant digits and things like that when you're rounding and when you have a bunch of zeros, how to make things clear. All right, let's do a little more practice here. Let's see if we can copy and complete this table. We're going to round decimals to the nearest hundredth, right? So that's going to mean 2 digits after the decimal. All right, so to get from a fraction to a decimal, we're going to simply just divide on a calculator. 1 divided by 10, okay, if we don't know this one, is 0.1. Okay, and as a percentage now, to show how to change to a percent, all we're going to do is move the decimal 2 places to the right. So the decimal would move there. We need to fill in a 0. So this as a percentage now is 10%. Okay, 1/10, 10%. The next row now we have 0.2. Okay, let's change that to a fraction. That's what we've been doing. So we take the digit after the decimal, and when there's only 1 digit there, so the denominator is 10, right? It's 2/10. And we know that is reducible. Divide them both by 2. We will get 1/5. Okay, to change to a percentage, we're moving this decimal right here 2 to the right. So I'll just do it on the side here one more time. So it was 0.2. If we move that to the right twice, 1, 2, the decimal's now there, and we have to fill in a 0. This is now 20%. Okay, how do we do it the other direction? How do we go from 25%? How do we turn that into a decimal? Well, if we move the decimal 2 to the right to make it a percent, we're going to move our decimal 2 to the left. So think about right now, it's here. We're going to move to the left, 1, 2. Okay, so the decimal now is in front of the 2. Okay, and the reason we're moving 2 places is because percent literally means to divide by 100. Okay, cent, like you think of a century or a cent in money, a penny is 1/100th, right? So percent is divided by 100. That's why it's 2 decimal places. Okay, then how do we turn this decimal into a fraction? 0.25 is 25 over, there's 2 digits, so it's tenths and hundredths, right? It's 25 over 100. And those can both be reduced, right? We can divide 25 and 100, divide them both by 25. You'll get a simplified answer of 1/4. Okay, think about money again. 0.25, 1/4, right? 1/4. All right, how about 1/3? They gave us the percentage, okay, is 33 1/3%. If you want to change a fraction into a decimal, you can always just do division. And I'm dividing to see it's 0.33. Okay, they wanted us to round to the nearest hundredth, so that's why I carried 2 decimal places there. Okay, technically, we could write this as 0.3 with the bar over it, because it's 0.3333333, right? This is a never-ending decimal. Okay, it does have a repeating pattern to it, though, right? Okay, 1/2, 1 divided by 2, of course, is 0.5. Okay, and we could put the 0 on there if we want. We could actually have done that up here if we wanted to round to the nearest hundredth, but we don't have to, because remember we showed before, as long as it's zeros after the non-zero digit, they really don't change anything. But that might help when we want to write it as a percentage. Okay, to make the 0.50 into a percent, we're simply going to move that decimal 2 to the right and come up with 50%. Okay, which definitely should align with 1/2 as a fraction. Okay, the next row, 0.6. If we want to change that to a percent, same thing. We'll move that decimal. Again, I'll show if it's 0.6, and we move the decimal 2 to the right, the decimal is now there, so it becomes 60%. And as a fraction, okay, it would be 6/10, right? Because it's only 1 digit, so it's a tenth place. So 6/10, which is reducible. We divide them both by 2. So 3/5 is 60%. Okay, 2/3. If we divide 2 divided by 3 on the calculator, this one now is going to be 0.6666 repeating. So if we're rounding to the nearest hundredth, right, we need to make that we need to make the hundredth digit a 7, because 0.66 would round up. That last 6 gets rounded up to a 7. Okay, what about 0.75? Okay, some of you guys might already know the simplified answer, which is great, but just to show the process again, 75 1/100ths, right? If you divide them both by 25, that's where the 3/4 come from. Okay, and as a percentage, of course, 75%. 80%, moving that decimal back to the left to become an actual decimal would be 0.80 or just 0.8. Okay, we could write this, we could think of it again as 0.8, which would be 8/10, as opposed to doing 80 over 100. And divide those both by 2. We get 4, oops, sorry, that's a little tight in there, 4/5. And then finally, 9 divided by 10, calculator problem, is 0.9. We can throw the 0 on if we want to. And of course, as a decimal, 90%. Okay, so hopefully we're comfortable. Practice these a little bit. Calculators can definitely help getting the decimal form, and then moving the decimal back and forth to get from percentages to decimals. Okay, so the assignment I'm going to have you guys do a little brief one today. We're just going to do numbers 9 through 11 here in section 4.1.